highly demanded skill in the software industry. Services, multiple profile, architectural style. Hello everyone, very warm welcome to Think Constructive. I am Isha. Today I have got an extremely important session for you, that is session on microservices. This is one of the highly demanded skill in the software industry and also the topmost demanded session on my channel. So don't leave the session in between because I will be covering microservices right from the beginning. That means, first of all, why should we have microservices? What were the problems with the previous architecture? What solutions does microservices provide? Followed by the Java Spring Boot Microservices Demonstration. And I will also be covering who are using microservices. Alright, so stay tuned. Watch the session till the end so that you don't miss upon anything. Let us quickly start with the need of microservices first. First thing I'll be talking is why microservices. So before starting with any concept, we should actually understand the why behind it. Why that concept has arrived. Why that concept is getting popular. What were the challenges we were facing earlier which are getting solved by using this current concept. Alright, so all these things are extremely important to understand. So that is where I will be first talking about why microservices, and then we will move towards what are microservices. Alright, in order to understand why of microservices, first to understand monolithic architecture is extremely important. Prior to microservices, in the older software which were already developed, monolithic architecture was used. So we will now understand monolithic architecture because then only we will be able to discuss its challenge, and then we'll proceed with the microservices architectural discussion. Alright, so monolithic. What do we understand from the term mono? Mono means one. That means monolithic means everything is clubbed inside one. So how the monolithic architecture application will look like? Something like this. Right. So this dotted line you can visualize as an application. Okay. And inside this application, you can see user interface, business logic, and data access is written. So all the required components are written inside this. So that means what is happening inside one application, all piece of logic, all required components which are interfacing with different components also, and whatever feature or functionality code, everything is written inside one application. That is where this application is called mono. So one application mono will have all the clubbed code inside it. Alright, further you can see this application is getting some HTTP request and responding back. Similarly, it is able to access data from database and responding back. But for all these functionalities, this complete one application is responsible. Right? So that's how the monolithic architecture will look like. Now let us have a look on some of the key points of monolithic architecture. So we will simply call monolithic architecture as single logical executable. Why? Because all the components are written inside one application, and wherever that application is needed, that single logical executable will be created and will be deployed. And that single application will be responsible to serve everything. Alright. And since it is single logical application which is doing everything, that is where we call it as a tightly coupled application, because only one application is serving everything. It is, interfacing with the HTTP request response. It is interfacing with databases. It is providing the user interface. It is providing all the feature functionality, logic, code, and also it is interfacing with databases also. Right. So all the components are written inside one application, and that complete one application is responsible to serve everything. That is where we call this kind of architecture as a tightly coupled architecture. Alright. Now let us understand more about monolithic architecture with the help of one application or one example. So let's take a social media example. I've taken this example because everyone understands social media very well. Alright. So here you can see in this blue box, There is a user, there is a profile, there are posts, there are notifications, and many more. That's how the social media, any social media application will look like, right? You take an example of Facebook or Twitter or LinkedIn. Any social media application will have bare minimum these many functionalities. It will have users, and then for those users, it will have users' profiles. For those users, it will have users' post, then notifications for those users, and many other features, right? And who is interacting with this social media application? There is a client. So this client can be you, me, our friends, family, or anyone else, right? So these clients are going to interact with this social media application to access their profile, to access their notifications, or to create new post, or to comment on someone's post, react on someone's post, right? Put some articles or change their profile. So there can be many more functionalities, isn't it? Now let us assume that I have built a social media application with the help of monolithic architecture. That means one application will be having all these functionalities. Currently I have written only 4 functionalities, but there are many more functionalities, n number of functionalities. And it's not only about functionality and logic, it's about having their user interfaces, their DB interactions, their different interfaces they will be opening, right? So for all those things, there is only one application which is responsible to serve to millions or trillions of clients, isn't it? So there are many users who are interacting with this social media application. Let us assume I have built this application with a monolithic architecture, which I have displayed here. So now let us assume because of some reason, this application goes down. What will happen? Everyone will be impacted. Now let's move towards the challenges and see what kind of challenges or problems we face when we design any application with the monolithic architecture. All right, I'll keep referring this example. So just keep this picture in your mind. That will be helpful to understand it. Here are some key challenges which we face when we use monolithic architecture. First and foremost is it will become a very big complex application, isn't it? What happens, like we have just now seen in our social media application, there are many functionalities or many features and many interfacing. And if everything is clubbed inside one application, that application will become extremely complex to manage, isn't it? To maintain and to grow also. Another important point is technology dependency. That means the application is written in whichever technology, only that technology can be used to maintain and grow that application. Later on, because of any reason, if developers or architect wants to change the technology for that application, it is not possible. It is only possible if they decide to go ahead and rewrite the complete application using some other technology. Like you can assume many years back, if the application was written using mainframe technology. But nowadays, Java is very popular and developers want to write application using Java or want to write more features using Java or Java's latest framework. They won't be allowed to do so because application itself won't allow them, right? So there is a rigid technology dependency on the monolithic architecture. All right. Next important point to understand is people dependency, right? One big complex application was written long back by some group of developers. Now later on going forward, this application, since it is growing big and complex, it needs more people. First of all, the same technology understanding people will be needed. And on top of that, the people will have to put in a lot of effort to understand the complete application. Since the application is big and complex, it will take a lot of time for anyone to learn it, right? That is where I say it involves a big learning curve. Slow development cycle. Obviously, why? Because it is a big complex application. So any small change in the application can cause a huge impact in the entire application. So first of all, the person should have a very, very good understanding of that application, and then still they need to be, very sure about even that small change. And it's not about only doing the change, it includes the deployment also. So even for the smaller changes, the complete application from the production side has to be taken a downtime, and then the newer changes will be deployed. And if there are any flaw in the newer changes, which unfortunately are seen in the production, the entire rollback procedure should also be applied. That will involve another huge cost, right? So entire development cycle will become slow here. And then more quality issues it can have, as I explained, because it is a complex application. So any small change can impact a lot many other things. Everyone cannot have the complete understanding of the application, right? So what happens if there is anything, any small thing which is overlooked, it can cause bugs which can be seen in the test bed, in the pre-production, or it might happen in the production directly. Those bugs are seen, and that is very bad, isn't it? Limited reusability, right? Since every component, every feature, every logic is embedded in one big application, so that application cannot be reused elsewhere, right? It can be, I'm not saying that not possible, but it will become very cumbersome to do so. That is where its reusability becomes very limited. Another, limited scaling. When we talk about scaling, okay, we assume no worries, I'll deploy more and more instances of the application, which is fine, but it's not only about deploying the instances, it's about the cost of deployment also. So whenever, huge application instances will be deployed, it will be a huge cost from the hardware side. And if you are using cloud architecture, even in the cloud, lean applications are preferred because that will cost less in the cloud world. So if you will deploy more and more huge big instances of any application, even in the cloud, entire infrastructure requirement goes up, which will shoot up the cost, and hence it will limit the scaling. This is one. There are many other reasons for that also. And then new technology adoption is very costly, as I explained in point number 2. If finally your architects and designers and developers have decided that you want to use another technology in this application, you have to take a tough decision to rewrite the entire application, because in the current monolithic application, such kind of technical or technology changes will be very difficult to do, right? So these are some key disadvantages or challenges which we face in the monolithic architecture. There are more, but I have listed some important ones here. All right. So now, because of such challenges, people started thinking about a different architectural patterns or different architecture which will, minimize these challenges. I will not say that, new architectural changes or patterns are going to zero down these things. Technically, it is hard to say, but yes, to minimize such challenges, there is another architecture which is microservices. So now we will learn what are microservices, how we solve these problems using microservices. All right. So now let us first see what are microservices. We interchangeably call it microservices or microservices architecture. Okay, so what happens when we use microservices architecture? Something like this. What are we seeing here? Too many services and centric is domain. So that means whatever is the business domain or business logic, multiple services are built around them. That means there is no more tight coupling, or there is no more one application which is holding everything, all the interfacing, all the features, all the functionalities, all the logic. No, right? Because due to that, we faced a lot of challenges as we have just now seen. So what was the solution in order to overcome all those problems? First, very important problem what we remember is tight coupling. Because things were so tightly coupled and clubbed together, those were creating a lot of problems. So the solution is to disjoint things from each other and make them loosely coupled. That's what has happened in microservice architecture. Multiple services should be created and each service should have their independent responsibilities, right? No need to mix up the responsibilities in one service or one application. Rather, break them up into single individual responsibility, right? Every service will be now fulfilling their own responsibilities and no more dependencies on, any other service, and no more tight coupling. All right. So here is a, definition for microservices. So microservices or microservice architecture is an architectural style that structures an application as a collection of autonomous small services. So multiple services are created with their own set of responsibilities. All right. So here is a more detailing about microservice architecture. There will be multiple services in case of microservice architecture, and those will typically look like this. So here is a UI service, okay? And there is service 1, service 2, service 3, likewise n number of services, okay? So what we have done, whatever functionality, features, interfacing, everything was written earlier inside one application. All those things are now broken into multiple services like this. So what we have done, we have created one separate UI service which will be talking to the clients. And for feature and functionalities, there are separate services which is having their business logic. And further, if needed, they are talking to databases. All right. And if required, these services can talk to each other also. Okay. Now, let's have a look on the social media example. If we design the social media application with the help of microservice architecture, how that will look like. Okay, so it will look like this. This is my client, like me, you, your friends, colleagues, whomsoever is using social media application. Okay, they will be sending requests to UI service. So for UI interfacing, there is a separate service altogether called UI service, and further, basis on the demand, UI service will be talking to the user service. So earlier we were seeing in blue box, user, profile, post, notification, everything was clubbed inside one box. That means one application. Now there is a separate application called user. There is another application called profile, one more post, one more application called notification, and many more, right? And there is a separate application for UI service. So if needed, UI service will be talking to user, or UI service will be communicating with profile or post or notification or whichever service is needed. Okay. These applications or services can talk to each other, and if required, these services have their own separate databases to access data, right? So they can communicate with the databases if required. So you can notice there is no database sharing in the microservice. Why? If database will be shared, this service or any service will not be microservices. Why? Because microservices are small services holding single responsibility. So here in case of user, you can see this user service is holding all the user required thing. That means user database. That means username and password in simple term. Okay. So it will be talking to the database for that. There is another service called profile, and this profile service will be having each user's profile information in its own database, right? For that, it's not going to talk to this database. Rather, it is maintaining its own separate database. So let's say for user 1, profile information is needed. So this user service can directly talk to profile service and get the details. Or if through UI service it is needed, UI service can send the user information let's say user ID, and get the user's profile details back to UI service. All right. Likewise, for a particular user, what all post user has created, if those kind of information is needed by UI service, what UI service will do? Will send the user identification to post. Post will fetch for that user ID relevant post from the database, give it back to UI service. Similarly for notifications and whichever other services, right? Now here you can assume if there is any change, let's say in the notification service is needed, any new feature needs to be added here. Developer will be doing that changes in the notification service, tester will be testing that, and only this service will be deployed. Every other service will remain working, will remain unimpacted. So actually, client will hardly know that there is any downtime or any problem or any disturbance in the service because he is working seamlessly. Okay, for a couple of seconds notification he was unable to see, which is fine, right? So that's how microservice is helping a lot. And that is the reason it is getting so popular in the software industry. All right. Now let's discuss monolithic versus microservice, and then we will be discussing microservices features, advantages, all those stuffs that will be followed by a demonstration. So what we have seen in terms of monolithic, my application is looking like this, isn't it? Everything is written inside one application. And in terms of microservices, how my application is looking like? It's a set of services, multiple services, right? Each service is having their own databases, talking to UI and further talking to client, right? So set of services are here, not a single application. Okay. Now let's move from here. Now let's talk about some of the microservices features and advantages. All right. Here are some key features of microservice architecture. These are small independent services as we discussed. Another important point is it communicates over REST APIs. That is where the REST API is very popular. All the microservices, you write it in whichever technology, but one thing is important and mandatory. It should be able to communicate over REST APIs, right? It should be able to receive the REST request and give the response back. Okay. Then loosely coupled, there are set of independent small services, right? So every service is having their own independent single responsibility. That is where we are calling it as loosely coupled. It is language neutral. This point is very important to understand. When we say microservices language neutral, that means, let's say I am a Java developer. I know Java very well, and otherwise also for the particular service, I know all the Java features, libraries are available. So it can be developed using Java very fast. Okay, so I can write this service 1 using Java and related framework. Now there is another group of developers who knows .NET very well and they know all sorts of .NET library and they are supposed to write service 2. They prefer writing it using .NET technology. No problems. They can write their service 2 using .NET technology. I can write, or my group of developers can write service 1 using Java technology. Only one requirement is mandatory. These services should be able to communicate with each other with external world using REST APIs. Correct. So we should be writing the services in such a way that we should be exposing REST APIs. That's all. Underlying, I can use any programming language as a developer to write that particular service. Yeah, within one service, one programming language is fixed, correct? But across services, it can vary. That is where we say it is language neutral. Makes everyone's life very easy, isn't it? Fault isolation. This is an extremely important feature of microservice. That means every service is small, having independent responsibility. So if there is any problem occurs in that service, it can be fixed in that service itself and redeployed in the production without disturbing any other feature, any other functionality. Again, it will be kind of seamless for the client because they might not know this impact at all, or they might know for a very short span of time, Also, it is very easy to find any issues, any bugs in the particular service because services are small. Team knows it very well. So even if there is any problem identified, they can fix it very quickly. They can act on that problem very quickly. All right. So every service's issues, faults becomes isolated from another one. Now let us see some advantages. Actually, features and advantages we can use interchangeably. So there are some more advantages or features I would say. First one is stateless communication. That is, each request response pair is an independent transaction. So this is actually the feature of REST APIs. Since microservices communicates over REST APIs, they also have this feature. That means the entire communication is stateless. Each service is responsible for its own data. As I showed you in the architectural diagram and also in the example, that every service is having its own database. Database is not shared among the services. Rather, each service is having their own independent database. So every service is responsible for its own data only, right? And if services needs each other's data, they will communicate with each other using REST API and would get that data, right? They won't interact directly with other services databases, okay? It is less people dependent or a small learning curve. Both points satisfied here. Why? Because services are small. So each service's development and testing teams are small and they need to know only that service, right? Since services are small, so learning curve will automatically become smaller because smaller things are there to learn. Few set of features, small code base is there to understand, and that makes it less people dependent, right? It's not like that everyone has to know the entire huge big complex application architecture, internal code base, internal functionality, everything not needed, right? Because every service is having their small code base, only that much learning is needed. That makes it less people dependent because to ramp up people quickly to make that service understand becomes very easy. Small development teams. Why? Because each service is small. So obviously their development team's requirement will be smaller. Faster development and deployment cycle because each service is small. So if there is any other functionality or any new thing needs to be added or any bug needs to be fixed, they can quickly be fixed in that small service and deployment will be very quick, isn't it? Because huge service deployment time will be more. Small service deployment time will be very small, right? Lesser quality issues. We have already discussed this point, right? Because since a smaller code base, so quality issues will automatically become smaller. And if it comes, it can be fixed very fast. Highly scalable and highly reusable. First, we'll discuss scalable. Services are smaller. So even if their instances deployment requirement is huge, they will be less costly because small instances, multiple instances can be deployed even in the cloud infrastructure because cloud is very supportive for microservices architecture. So n number of instances for same application can be deployed and those will be less costly because services are smaller. So infrastructure requirement will become smaller for that. And highly reusable. Why? Because single responsibility services are developed. So those can be fitted into one domain and the similar service from this domain can be reused in another domain also. So for example, in our social media application, we talked about notification service. Definitely it is used there. I have built that notification service. Now down the line in my organization only, some other team is working on the e-commerce side application and they also need to have the notification service. So same notification service can be plug and play there also. So that team need not to think all together and develop the notification service. Rather, they can just use it, right? So that's how microservices will become highly reusable. Quick adaptation of new technology. So new technology adaptation becomes very fast in microservice architecture. As we discussed, that services are smaller and there are smaller development teams working on that. So if at all there is a need for having a new technology in the service, it is very quick and easy to do that. All right, I've listed down key features or the key advantages of microservices architecture. All right, so let us now quickly move towards what all frameworks are available for implementing microservices. I'll try to cover the important ones here. First, extremely popular framework for microservices implementation is Spring Boot using Java. So among Java developers, Spring Boot microservices implementation framework is extremely popular. It has got rich set of features and libraries available that makes microservices implementation very easy. Another one is Oracle Helidon, that is also for Java developers, but yes, Spring Boot is more popular, I would say. Another one is Micronaut, that is JVM based full stack framework. I think it is relatively new. Then we have for Golang developers, GoMicro. For Node.js developers, it is Molecular, and there are many more. I have listed down a couple of important microservices implementation frameworks here. All right. Now let's have a quick demonstration. For demonstration purposes, I have developed two Java Spring Boot microservices. One is user service, another one is profile service. So you remember we discussed social media application example. So from that, two services I have picked up. One is user, another one is profile, and I have developed both the microservices using Java Spring Boot. All right. So in this session, I will be demonstrating the functionality, right? The code explanation and all those stuffs I will be covering in my subsequent sessions. I'll switch to IntelliJ IDE editor now and will show both the services to you, and then I will demonstrate their execution. All right. So here is the user service. In this user service, you can see I have exposed a get user. So basically, basis on the user ID, a get users mapping is exposed. So I have written a method called get user, and basis on the given user ID, it will return the user's information, right? And what I have done, I have exposed the get mapping, and the value it should be taking as user ID. And what is the request mapping? /user. All right. So first I will bring up this service and will show you what output does it give. And then I will show you the profile service. Okay. So let me just bring up this application. So you can see in the log, my user service application is started on Tomcat port 8080. All right. Now I will switch to Postman and will show you the functionality. So this is my Postman tool, and here in this user service, I have written the URL. Okay. So localhost, since my application is deployed in the same machine, and port 8080 we have just now seen, and after that in the request mapping we have seen /user we have exposed, so we have written that here, and here I have given the user ID as 1. Okay, and here in the IntelliJ you can see for user ID 1, username 1, and phone number XXXX will be returned. So for this demonstration purpose, I have hard coded the user values and I am returning that. All right. So here in the Postman, the moment I will send this request, what response I am getting? I am getting user ID as 1, username as 1, user phone number as XXXX, and I will get back to this point. All right. So my user service is up and running and able to give me the values for the requested user. Okay. So there is no real-time database communication in this service. Currently, this is only returning a hard-coded response. Okay. Because I have done this only for the demonstration purpose. I'll just quickly show you this user model class also so that you can understand how you are getting 4 attributes. So here is a user model class. It is having user ID, user name, user phone number and a profile attribute. I'll come back to this profile. Okay. Now I will show you my profile service. So here is my profile service. In this profile service, you can see request mapping / profile is done. Okay. Get mapping, profile ID. So basis on the profile ID, it should be able to return the profile details. Again, this profile service is not talking to database right now. Rather, it is returning the hard-coded response. Okay. So whatever profile ID will come, it will be able to return these details. Okay. What is it returning? New profile, profile ID, post and notification. So post and notifications are list for which we have created some values here. Okay. And I'll show you profile model class also. So in this profile model class, you can see profile ID, list of post and list of notifications. These three values we are returning. Okay. And this application.properties, you can see server port I have given as 8081. That means this profile application will work on port 8081 because what I would want, I want both applications should be up and running together, and then I will show you how they are talking to each other. All right. So now let us bring up this profile service application. My profile service application is up and running. Here you can see started profile service application and Tomcat started on port 8081, right? This is what we have seen in application.properties. Okay. So now let us test this profile service from the Postman. So what is the URL? Localhost, and this port will be 8081. Okay. Profile. And then profile ID I am giving as 1. Let me send this request. What am I getting? For profile ID 1, list of post, which is holding value post 1 and post 2, and list of notifications holding notification 1 and notification 2. All right. So now what we have done? We have bring up our user service and profile service. I don't have any UI service right now. So what I would like to demonstrate, if for a particular user, profile details are requested, how those details are provided with the help of user service, right? Now next thing I will demonstrate, if in user service, for that particular user, profile details are requested, how it will get that. Okay. So I'll go back to IntelliJ. Here in IntelliJ, you can see in the user model class, we already have an attribute called profile. We want to return for this particular user, user1, the profile details also along with this username and phone number. All right. How do we do that? I'll just quickly paste a piece of code here. Okay. And we'll explain it. So by using this piece of code, what we have done, we have included this profile value also in this user1 object. Okay. And when we return this user1, it will be holding this profile value also. And what is it doing? Internally, directly it is calling this profile service, which should be up and running. How can we do that? We can do it with the help of REST template. So REST template is a client application, okay, which allows you to create the HTTP request and get the response back. Okay, so we have created REST template object, and in the REST template object, we are directly calling get for object. Okay, what this get for object will ask, it should have the real URL where it should be, going ahead and requesting for something and what value it will return. So what we are expecting, it should return us the profile. That is where we have given profile.class here, and here the real URL. This is the URL which we used in our Postman also, localhost : 8081/profile/profile ID, which in this case we are using as 1. Okay. So what this call should return to us, the profile object, which should have the profile values corresponding to profile ID 1. Okay. And the moment we get this profile, we will set this profile here in the user1 object. Okay. And we'll return this user1. All right. I hope this part is clear. I'll just save and restart the server. Only for user service application, because we have just now done the code changes here. There is no code change in profile service. So we are not even touching that. So my server is restarted. You can see started user service application and Tomcat started on port 8080. All right. Now we will go back to Postman and again trigger the user service. Earlier we were getting profile null here. Now when we send the request, what we are getting? User ID as 1, user name as 1, user phone number XXXX, and the profile detailing as profile ID 1 with the list of posts and list of notifications. All right. So what we have done, we have seen two services, more precisely two microservices communicating with each other. One microservice is holding only user information. Another microservice is holding only profile information for respective users. And they are capable to communicate with each other over REST. All right, that is where I say it. I call it as a microservice. So this is a very small example of microservice. In my subsequent sessions, I will be telling you how to create microservices using Java Spring Boot. Full-fledged microservices we will be doing in the later sessions. All right. Now let's see who are using microservices architecture. Okay. So a plain simple answer is those who were not using earlier also are migrating towards microservices very fast. I would say very fast. Okay. So many legacy applications are being transformed into microservices applications. Okay, so let us have some examples now. So Facebook, LinkedIn, Twitter, we all know all this, right? We all use all these things. Netflix, Paytm, Amazon, Nokia, and many more. These are very few names I have mentioned. There are many more organizations who are already using microservices architecture or are moving towards microservices architecture because of the benefits it provides. All right. So to summarize what all we have covered in this session, we understood what is monolithic architecture, and why we understood this architecture, because we wanted to understand the challenges and the need of having microservices. All right. Then we have seen monolithic application example followed by disadvantages of monolithic architecture or challenges which we face using monolithic architecture. Then we understood what and why of microservices architecture, followed by example of microservice architecture. We discussed social media application example in both the cases, monolithic application as well as microservices architecture. All right. Then we have seen monolithic versus microservices. We also covered features and advantages which we get using microservices architecture. Many key features or advantages I talked about for having microservices architecture. That was followed by microservices implementation frameworks, rather key frameworks. That was followed by Java Spring Boot microservices demonstration. We have seen two microservices talking to each other. Okay. And then we talked about who are using microservices architecture. All right. I hope this session has given you a very clear picture of monolithic architecture as well as microservices architecture. In my next sessions, I will be talking about how to implement microservices using Java Spring Boot framework. All right. If you have any doubts or you would want to ask anything, please ask your doubts in the comment section below, and also tag the timeline which you found very helpful to you, because that will be helping others also. Thank you everyone for watching this session. I hope you found it useful. If you like the session, hit the like button and subscribe to the channel and also ring the notification bell so that you are always updated with the new upcoming sessions. I'll continue bringing more and more Java, Spring Boot, microservices and related technology sessions here. So stay connected and keep watching Think Constructive. There are more Java Spring Boot sessions available on this channel, so feel free to explore them. Also, I would like to request you to share the channel and session details with your friend, family, and colleagues so that we grow together more stronger as a community. Thank you once again. See you in the next session. Bye for now.